Hello, my dear students. Welcome to IMS Academy. Myself, Sandeep Adari. Now, in today's session, we would like to discuss about some of the important questions on geotechnical engineering. So, as part of the GATE score booster, I'll be starting the topic geotechnical engineering. In that geotechnical, we have different topics like properties of soil, which we can expect a definite question. So, if audio video clear, please comment in the comment box. Now, my dear students, when I talk about geotechnical engineering, properties of soil, we can expect 100% question. Or if we talk about shear strength, we can expect a question. Consolidation, we can expect a question. Pile foundation, stability of slopes, shallow foundations. These are the topics where we can expect 100% questions. And that means that remaining topics are not important. You should give extra attention for these topics. Now, my dear students, let us solve some of the important questions. So, these are one of the GATE 25 questions we have. For a partially saturated soil at a construction site, water content is given as 15 percentile, degree of saturation is 67 percentile, void ratio is 0.6, specific gravity of the solids is 2.67. Consider the unit weight water as 9.81. Okay. To fully saturate 5 meter cube of soil, what is the weight of water required? Now, my dear students, whenever these kind of questions are asked, the question is very simple. So, please try to understand here. You know water content is equal to what, my dear students? It is nothing but weight of water upon weight of solids. So, here when you ask me, what do you mean by weight of water? Weight of water is nothing but water content to weight of solids. Now, let me tell you, my dear students, it is a question related to the extra amount of water, because for fully saturated, the amount of water content will be different compared to the natural water content. So, extra amount of water required or extra amount of water added, any kind of this question will be solved in the same way. So, first you have to calculate the difference in the water contents, that is water content 1 minus water content 2 into weight of solids. Okay. Now, my dear students, when they use the word extra, then only we find the difference in water content. You should understand always, my dear students, dry density is nothing but weight of solids upon total volume. So, here weight of solids can be written as gamma D into volume. So, this is the concept where you should be very clear. So, when they ask you what is the extra amount of water to be required or added, any kind of these questions, just try to plug in the values water content 1 minus water content 2 into gamma D into volume. So, this is the formula where we have to use. Now, my dear students, when I talk about dry density, what is the formula for dry density? So, let me tell you, when I am explaining this problem, it is not only just solving that problem, I will give you some insight where it is required. So, here gamma D is given as the formula. Gamma D is equal to gamma W into G upon 1 plus C. So, this is the formula for what, sir? Dry density, my dear students. So, let me tell you how to remember this formula when you are solving a question on properties of soil. So, usually I encourage students to remember gamma is equal to gamma W into G plus E into SR upon 1 plus C. Here, my dear students, what do you mean by gamma? Gamma is nothing but the unit weight of soil. So, there are two conditions. Let me tell you, my dear students, people have this confusion. Sir, when I tell you saturated unit weight or dry unit weight, first of all, it is nothing but bulk unit weight. So, the bulk unit weight in dry state, we call it as dry unit weight. The bulk unit weight in saturated state is called saturated unit weight. So, when I say saturated unit weight, we can say degree of saturation is equal to 1. In that case, gamma sat can be written as gamma W into G plus E upon 1 plus E. Now, my dear students, please try to remember this formula so that all the unit weights you can remember. And remember, in dry condition, when I talk about dry condition, my dear students, when I talk about dry condition, what is the degree of saturation? Any idea? Please comment in the comment box. So, in dry condition, the degree of saturation is nothing but equal to 0. So, when I plug in this SR is equal to 0 in the equation, we can say dry density is nothing but equal to gamma W into G by 1 plus E. Now, in this problem, it is a GATE 25 question. We have to solve what is the given data here. What is the given data? Here, if you see, my dear students, the specific gravity is given as how much, sir? 2.67. Here, the specific gravity is given as 2.67. And the initial water content is given as 15%. Right? And now, we have 2.67. Now, what we have to do? Let me tell you. Here, void ratio, an important formula we have, very, very important concept, my dear students. An important formula here. The important formula here is the relation between void ratio, degree of saturation, water content and specific gravity is given by the formula E into SR is equal to water content into G. As I told you, in fully saturated state, degree of saturation will be equal to 1. So, in this case, if SR is equal to 1, water content can be written as E upon G. So, what is WC? WC is nothing but the water content in which state, sir? In fully saturated state. This is the formula in case of what state, my dear students? In case of fully saturated state. Now, as you told, always remember, my dear students, G, what is G? G is nothing but true specific gravity. And the true specific gravity is always constant for soils. So, when I talk about true specific gravity is given as gamma S upon gamma W. So, what is G? Gamma S by gamma W, which we call it as unit weight of solids to the unit weight of water. Now, here, if I see here, the degree of saturation is 60%, void ratio is 0.6. Okay. So, here, if you see, water content is equal to, void ratio is 0.6 divided by specific gravity is 2.67. Can anyone comment in the comment box what is this value, sir? Now, if you calculate this, you will get a water content value as 0.2247. Okay. 0.2247 is the water content at fully saturated state. This is the water content at where state, sir? Fully saturated state. Now, we also have to calculate what, my dear students? Dry density. So, what is actually the formula for dry density? Dry density can be calculated as gamma D is equal to gamma WG upon 1 plus E. Here, what is the unit weight of water? Sir, see, always the standard thing they have given in the question also, the unit weight of water, that is nothing but gamma W, which is standard, you can say 9.81 kilonewton per meter cube. But remember, my dear students, whenever you are solving the problem competitively, or when the time is less, some of the exams like state level or ISRO or BARC, you take it as, you try to solve in tons, 1 ton per meter cube, and whatever the final answer you got, that you just try to multiply with 9.81. So here, if you plug in this value, here gamma W is nothing but 9.81 and the specific gravity is nothing but 2.67 upon 1 plus E is 0.6. Now, if you plug in these values, see here, my dear students, you will get dry density is equal to, what is the dry density value we got? We got the dry density value is 16.37 kilonewton per meter cube. Okay. Now, you know what is dry density. Okay. You know what is dry density. After finding the dry density, they have given clearly. They have given you clearly for 5 meter cube of soil. So, here volume is also given. So, what is the volume, sir? Volume is nothing but equal to 5 meter cube. So, when I ask you extra amount of water to be added, when they ask you what is the extra amount of water to be added, or water required or water added, whatever, anything, my dear students, you can just plug in these values here. This is equal to what, sir? Gamma D into volume into water content 1 minus water content 2. Here, if you see, my dear students, you got dry density is almost equal to 16.37 into volume is 5 into water content is 0.2247 minus 0.15, which is given in the question. So, if you solve this, you will roughly get an answer of 6.11 kilonewton. The answer is, you can round off to 6 kilonewton. So, please write down this, my dear students. Please write down that, my dear students. Okay, I hope you are clear. Now see, students, whenever we have a question from properties of soil, if you are preparing for the GATE questions, please understand short notes formula sheet is mandatory for any subject. So as part of this, when I talk about properties of soil topic, where we can expect 100% question. So let me give you the formula sheet for this topic, properties of soil. You know, my dear students, here, void ratio can be written as water content to G upon SR. Okay. Again, gamma is equal to gamma W into G plus E into SR upon 1 plus E. You can write here, my dear students, in dry density, the same formula, SR will be equal to 0. In gamma sat condition, the same formula you have to substitute, SR is equal to 1. We have another important formulas also, my dear students. So we have dry density can be written as bulk unit weight upon 1 plus water content. This is somewhat an important formula. I will tell you, my dear students, in properties of soil, you should be aware of all the formulas. If I talk about void ratio, it is volume of voids by volume of solids. When I talk about porosity, volume of voids by total volume. Sir, recently in one of the GATE exam, people don't know what actually is percentage of voids. There is two concepts, sir. When they ask you percentage, just multiply this with 100. Porosity can also be called as percentage of voids. If they ask you percentage of air voids, then it is volume of air upon total volume into 100, or you can write this equation also as porosity into air content. This is called what, sir? Percentage of air voids. Here we have void ratio, porosity and percentage of air voids. Now, my dear students, if you know, total volume is always written as volume of voids plus volume of solids. So here, my dear students, for a given soil, you can write this as Vs into 1 plus E. Okay. Now, my dear students, let me tell you one important thing. For a given soil, always remember that for a given soil, weight of solids, sorry sir, for a given soil, sorry, for a given soil, weight of solids and volume of solids. For a given soil, always remember weight of solids and volume of solids. Both are what, sir? Constant. So here if I see, this equation can also be written as V1 by V2 is equal to 1 plus E1 by 1 plus E2. Or you can say gamma D2 by gamma D1. So this is also another important formula when you are solving the questions. So when I talk about the porosity, void ratio, percentage of air voids, or if I talk about the bulk unit weight, and remember my dear students, always you should be aware of what is void ratio, what is porosity. And you might be aware, porosity can be written as E upon 1 plus E. And air content, in the name itself, it is related to air. So air content is nothing but equal to volume of air upon volume of voids. Similarly, if I talk about degree of saturation, it is equal to volume of water upon volume of voids. So my dear students, whenever you are studying properties of soil, you should be aware of these formulas at least. Okay, and remember always what is water content, which we have discussed. Water content is nothing but weight of water by weight of solids. And dry density is also known as weight of solids upon total volume. So I hope you are clear with the concept, at least on the formulas of properties of soil. And mark my words, I am in live also, I am telling you, 100% at least 1 mark question or 2 marks question, we can expect a question from this chapter for properties of soil. Now we have another beautiful question. This is also a GATE 2025 question. A 4 into 4 group pile with each pile of 20 meter long and 500 mm diameter installed in a square pattern, the average unconfined compressive strength and the adhesion factor neglect the bearing capacity at the tip of the pile. This meaning has a lot of significance. For a group of piles, efficiency is 1. The center to center spacing of the piles is. So this is the center, this is the length of the pile. So my dear students, let me tell you, first of all, what is efficiency of pile group? Let me tell you what do you mean by efficiency of the pile group. What is the efficiency of pile group? When I talk about the efficiency of the pile group, it is the ratio of average load on the pile to the ultimate pile. What, sir? It is the ratio of average load on the pile to the load capacity of ultimate single individual pile at which failure occurs. That is called efficiency. So here when I talk about efficiency, the average load on the pile group can be written as Qg by N upon ultimate load of single individual pile. If it is in percentage, you just multiply with 100. So here you can write here, efficiency can be written as Qg upon N into Qui. Okay. Now my dear students, let me tell you how to calculate. Sir, I am not concentrating only on this problem. Let me give you the insight or the concept behind it. Now when I talk about the group capacity of piles, when I talk about the group capacity of piles, when I talk about group capacity of piles here, there are two failures. What, sir? There are two failures. One is the individual failure. What, sir? One is the individual failure. Now, my dear students, calculate the ultimate load of a single individual pile and multiply with the number of piles, that is the individual failure. So here group capacity can be written as N into QUI, where N indicates number of piles and QUI indicates the ultimate load of single individual pile. So here QG can be written as N into FB into AB plus Fs into As. What is this formula? Let me tell you. Suppose here, my dear students, if I consider this as an individual pile, if we have a load here, okay, here the load can be transferred through friction as well as by underbearing, that is QB. Usually in the design of pile foundations, we always take combined underbearing and friction pile. Here the load is transferred both by friction as well as underbearing. So here QU can be written as QB plus QS. Here QB is nothing but FB into AB and QS is called Fs into As. What do you mean by FB, my dear students? Here if they ask you what do you mean by FB is nothing but the underbearing resistance. What is FB, my dear students? FB is nothing but the underbearing resistance. Now you have to calculate the area at the base. So usually the area at base, if I take, means it changes from pile group to. Here in the question they have given square pile group. Here let me take as a circular pile. Area at base will be taken as pi by 4 d square. Okay. Now my dear students, if I talk about Fs, what is Fs is, this is skin friction resistance. What is Fs? This is skin friction resistance. Okay. Here As is called the surface area. What is As here? As is nothing but the surface area. When I talk about As surface area, it is nothing but equal to perimeter multiplied by, this is what, sir? This is nothing but perimeter multiplied by length. Right? I hope you are clear, my dear students. So let me tell you, you are doing the problem using the ultimate bearing capacity. But in this problem, if you see, the end bearing resistance is not considered. So directly you can take Fs into As directly. Got it, sir? And if you see the question here, how many pile groups are there, sir? If you see here, my dear student, if you count the number of pile groups here, the number of pile groups is nothing but equal to 16. Okay. Now if you see, the overall length of the pile is 20 meter. Okay. And remember here, my dear students, he has given unconfined compressive strength. In most of the question, when the word unconfined compressive strength is given, you should know one concept here. Let me tell you that also. So here, a soil is said to be plastic equilibrium condition if all the soil particles are near to the failure plane. What, sir? A soil is said to be in plastic equilibrium condition if all the soil particles are near to the failure plane. So in this, when I talk about plastic equilibrium condition, my dear students, we have sigma 1 is equal to sigma 3 tan square 45 plus pi by 2 plus 2c tan 45 plus 5 by 2. In unconfined compressive strength, my dear students, the confining pressure is 0. So here whatever the sigma 3 is 0 and we have phi is equal to 0. If I take sigma 1 as the unconfined compressive strength, Qu will be equal to tan square 45 is 1, tan 45 is 1, it will be 2c. So C can be taken as half of the unconfined compressive strength. So the important key takeaway from this unconfined compressive, whenever the word unconfined compressive strength is given, cohesion should be taken as half of the value of the unconfined compressive strength. So let us see here, my dear students, like what we have given there. Okay. Now, just a second. We have now the formula. Efficiency is nothing but equal to group capacity by N into QUI. Okay. This is the formula. But here, my dear students, if you see the problem here, the efficiency is given, efficiency factor is given as how much? 1. The efficiency factor is given as how much, sir? 1. And remember, my dear students, there is no consideration of end bearing distance. That means when you are solving the problem, you should take the value of skin friction resistance only. So here when I take efficiency factor as 1, 1 can be written as Qg upon N into QUI. Or you can write N into QUI is equal to Qg. So here when I talk about N into QI, how many number of piles are given in the question? 16. For clayey soils, remember my dear students, for clayey soils, because it changes with respect to sandy soils and clayey soils. So I'm just giving you the formula for clayey soils. For clayey soils, end bearing resistance FB is given by the formula CNC. What is the formula, sir? FB, that is end bearing resistance, is given by the formula CNC. NC factor is taken as 9. And if you see the frictional resistance, skin friction resistance is given as alpha C, where alpha is the adhesion factor. Similarly, if you consider for sandy soils, my dear students, similarly, if you consider for sandy soils, what is the value of FB? FB is given as sigma V into NQ. Okay. What is FB, sir? End bearing resistance. NC, NQ, N gamma are called Terzaghi bearing capacity factor with respect to the cohesion, surcharge and unit weight, and they are the functions of phi only. And Fs can be written as K into sigma average into tan delta. Here, if you consider what is K, my dear students, K is called the lateral earth pressure coefficient, sigma average is the average effective stress, delta is the angle of friction between the wall and the soil. So here if you see 16 into Fs, what is Fs, sir? Alpha into C. They have given unconfined compressive strength as 100 kilonewton per meter square. This is the question data given. So what will be the cohesion, sir? Cohesion will be Qu by 2. That will be equal to 100 upon 2, which will be equal to 50 kilonewton per meter square. And the adhesion factor given in the question is how much, sir? It is given as 0.8. So 0.8 into cohesion is how much, sir? Cohesion is nothing but alpha C, which is 50. And here if you see, this we are calculating for individual pile. So individual pile diameter is given, and if you consider individual pile, AS is given as perimeter into length. So it will be pi d into L. So here what is the dia of the pile? Dia of the pile. What is the dia of the pile they have given, sir? I think it is given as 500 mm. Let me see. 1 second, student. The dia of the pile is given as 500 mm. So dia should be taken as how much, sir? 0.5 meter. So dia should be taken as 0.5 meter and length of the pile is given as 20 meter. So this, whatever the value which I have calculated here, is nothing for NQUI. Now we have to calculate the group. So when I talk about the group here, it is a square group, my dear students. Here it is what, sir? Here it is a square group. So for perimeter, square group, perimeter into length. Sir, see here. You can say, if I assume here, this I'll assume it as some B. Okay, all it is a square group pattern. So here B can be written as what? 3S plus D. Here B can be written as what, sir? 3S plus D. Okay, now when I talk about perimeter into length, we can write it as 4B, that is 4 into B into length is L. Okay, here we have 4BL. So my dear students, when I talk about group capacity, we take the entire group as a single individual pile. So we can write here is equal to surface area 4B into length of the pile is how much, sir? It is equal to 20. In the group, we can take alpha as normally consolidated 4B into 20 into C is into 1 into 50. If you solve this, you will get a B value as around, you will get a B value of around 5.026 meter. What, sir? But he is not asking what is the width of the entire pile group. Sir, here this is group capacity. Here we are multiplying with 16 and calculating the individual capacity. So when I talk here, width is nothing but equal to 3S plus D is equal to 5.026 meter. And here diameter of the pile is 0.5 meter, 5.026 meter. So if you solve this, my dear students, you will get a spacing value as 1.5 meter. Got it, sir? You will get a value of how much? 1.5 meter. Sir, the intention here is I want to solve the problem and I want to give you the insight of the concept. So whenever there is a concept related to pile group, they can ask you what is the ultimate load of single individual pile. So QU is nothing but the ultimate load with respect to the end bearing and with respect to the skin friction. You should understand, my dear students, FB is called the end bearing resistance, FS is called the skin friction resistance. Now you have to calculate what is base area, what is the surface area, and all these things. And always remember, surface area is perimeter into length. And efficiency is nothing but average load on the pile group to the ultimate load of single individual pile at which failure occurs. So I have given you the end bearing resistance. This is a very, very important table, my dear students. This is the table for both, and alpha will be taken as 1 for normally consolidated clays. So this is the formula for clay soils and this is the formula for sandy soils. So please write down these, students. See, whenever there is a question here, try to understand the question first. Try to, whatever the given data, try to have it. Whenever they tell something, it has some significance. So when they told end bearing at the tip of the piles is not considered, neglect means we should not consider that. And they have to see what they have asked, efficiency. Because efficiency usually expressed in percentage and we multiply with 100. But you have to see the value over there. So these things are very important. So please go through this slide, my dear students. Okay. We'll move on to the next question, my dear students. A designer used plate load test to obtain the values. A circular plate of 1 meter on a dry soil beneath the ground. The unit weight of the sand. The plate is loaded to a failure pressure of 1500. Calculate the Terzaghi bearing capacity factor. Now let me tell you one important thing, my dear students. Actually, there is a theory behind calculating the bearing capacity of the soil. My dear students, the theory here is the Terzaghi's theory. In Terzaghi's theory, my dear students, okay, you might have studied, sir, why do we assume some assumptions? We assume some assumptions to make the complex problem into an easier problem. We have n number of constraints. We will ensure that these constraints are reduced by assuming some assumptions. In Terzaghi's theory, we assume the soil is homogeneous. That means the properties are same in same directions. If the properties are same in different directions, we call it as isotropic. And remember, my dear students, in Terzaghi's theory, they assume general shear failure is assumed. There are different types of failures. General, local, punching. But in Terzaghi's theory, they assume the general shear failure. The shear strength is calculated by Mohr-Coulomb's equation. So, my dear students, when they ask you Terzaghi's theory, how to calculate the ultimate load, first thing, see, try to follow this order, my dear student. If you want to find out ultimate load for circular footing, I'm not only talking about this problem. You talk about the ultimate load for circular footing. So QU can be taken as 1.3 CNC plus gamma DNQ plus 0.3 gamma B N gamma. If anyone asks you what is NC, NQ, N gamma, NC, NQ, N gamma are called Terzaghi bearing capacity factors. And remember, my dear students, here when I talk about NC, NQ, N gamma, they are the functions of angle of internal friction only. Now, my dear students, they might ask you one important question. For a pure cohesive soil, what, sir? For a pure cohesive soil, if phi is equal to 0, for a pure cohesive soil, phi is equal to 0, NC is equal to 5.7, NQ is equal to 1, and N gamma is equal to 0. These also might be required in your problem solving. Now, my dear students, if they ask you ultimate bearing capacity for square footing, if they ask you what is the ultimate bearing capacity for square footing, here the ultimate bearing capacity for square footing is 1.3 CNC plus gamma DNQ plus 0.4 gamma B N gamma. Are you able to understand the order? If I take ultimate bearing capacity for rectangular footing, one plus 0.3 B by L into CNC plus gamma DNQ plus 0.5 gamma B N gamma 1 minus 0.2 into B by L. Sir, how to remember this formula? If I substitute in square footing L is equal to B, you should get here 1.3. Here 1 minus 0.2 is 0.8. 0.8 into 0.5 is 0.4. So in this way, you should remember the formulas. If they ask you for strip footing, similarly, they can ask you the other parameters also, my dear students. What is net ultimate bearing capacity? Net ultimate bearing capacity is nothing but QU minus overburden pressure, that is gamma D. They can ask you what is net safe bearing capacity. That is QNS is equal to QNU by factor of safety. And in the question, if they don't mention net, by default it is gross. Okay, here if they ask you what is gross safe bearing capacity is, QS can be written as QNS plus gamma D. Now, my dear students, in this question, we have a question related, the word plate load test is given. What is plate load test? Plate load test means it is the load at which, in plate load test, you will find out the ultimate load and ultimate settlement. So, when you apply load on a plate, there is standard plate sizes and square plate is generally used. We keep on applying the loads. The load at which the plate starts sinking is called the ultimate load, and how much the plate has been sinked, that is called the settlement. So that is what the actual concept behind the plate load test. Okay, you will do in a pit practically and you will know the ultimate load and the settlement. So here, my dear students, here let me tell you. First of all, there is another point. See, by default, you can write it as a note when you are solving the problems on shallow foundation or bearing capacity. The important note is when the footing is resting on a soil. What, sir? When the footing is resting on soil. When this word comes, when the footing is resting on the soil, when this word comes, sorry students, when this word comes, when the footing is resting on the soil, when this word comes, you should understand that depth of the footing is 0. Because there was GATE 2023 question also, they have given using this concept. Okay, they just asked what is the ratio of circular to the square footing. And another important note is, for cohesionless soil, means they won't tell it is a cohesionless soil. They can mention the soil type. They can mention the soil. Cohesionless means you can take examples for cohesionless soils is nothing but gravel and sand. But sir, you can take for cohesionless soils, you can take the example as gravel and sand. So for cohesionless soils, what will be the cohesion? Cohesion will be equal to 0. Agree? So if I consider here, my dear students, so here if I consider here, please see. Now a designer used a plate to obtain the value of bearing capacity of N gamma. We have to find the value of N gamma. A square plate, a circular plate. So it is what, sir? 0.3 gamma B N gamma of 1 meter diameter was placed on dry sand. When they placed on dry sand, C will be 0. And what is the other thing, sir? And you can say it is placed on sand means depth is also 0. So here depth is also 0, C is also 0. So here from this question, it is evident that C is equal to 0 and depth is equal to 0. So ultimate bearing capacity is given by the formula 0.3 gamma B N gamma. Sir, what is the ultimate load they have given? Sir, ultimate bearing capacity. The ultimate bearing capacity is given as 1500 kPa. So here QU is nothing but equal to 1500 kPa. So 1500 kilonewton per meter square is equal to 0.3 into gamma and B is how much, sir? Width is given as diameter or width is 1 and N gamma. So if you solve this, my dear students, you will get a value of N gamma approximately equal to 300. So the question is very easy. Let me tell you. Now, my dear students, if you want to solve any problems on plate load test for clays, settlement of the foundation by settlement of the plate upon breadth of the foundation upon breadth of the plate. If they ask you for sandy soils, these formulas are very important. Sir, SF by SP. What is SF? Settlement of foundation. What is SP? Settlement of plate. What is BF? Breadth of the foundation. What is BEP? Breadth of the plate. For sandy soils, this can be written as SF by SP is equal to BF into BP plus 0.3 plus BP into BF plus 0.3 whole square. And remember, in this case, in the first case, units are not a big issue. But in the second case, in this case, you should understand that breadth of the foundation and breadth of the plate, both should be substituted in meters only. Okay. This could be a question from plate load test. So please write down this, my dear students. Okay. I hope you have written this, students. Please try to write down the in and around concept of this. So this is the given data. This is the for ultimate bearing capacity for different cases. These are the notes. Please write down that. Now, my dear students, we at IMS Gate Academy, if you want to get any notification, job notification, or any YouTube notifications or any videos, you can join the Telegram group app and it will be given in the description. Now, this is one of the basic question and important question. This was also asked in GATE 2025. The bank of a canal has shown in the figure the material is homogeneous with a bulk unit weight of 20, undrained cohesion 30, saturated for the trial shape circle ABCD. Area is given as 150 mm square. The centroid is at P. Tension crack of 2.5 meter deep is also observed. Assume the unit weight water as considered 1 meter run of the analysis. So consider the canal is empty and the tension crack is completely filled with water. The factor of safety again is the failure. So this is a very, very important question, my dear students. Let me tell you, in slope failures, there are two cases. One is what, sir? Translational failure. One is translational failure and other one we have is what, sir? Rotational failure. What, sir? One is what, sir? Translational failure we have. Other one we have is rotational failure. What is translational failure? In translational failure, failure occurs parallel to the slope at some depth. Rotational failure occurs along a curved surface. So these are very important. When I talk about factor of safety, for translational failure, the factor of safety for translational failure, if they ask you, You should understand it is nothing but equal to shear strength upon shear stress. The translational failure factor of safety is given as what, sir? Shear strength upon shear stress. And you already know what is shear strength, sir? It is the function which depends upon the effective stress. So if you remember this formula, the factor of safety for translational failure is given by the formula C plus gamma z cos square I tan phi upon gamma z cos I sin I, where here I is the angle of infinite slopes. Usually translational failure occurs in infinite slopes. So using this condition, this is also another important question where we can expect this year. I'm thinking because previously 2022-23 we have seen this question. When they give you factor of safety for translational failure, factor of safety for translational failure in case of cohesionless soil, okay, and also seepage. Seepage means the water will penetrate into the soil and it acts beneath the foundation. So in this case, the factor of safety is given by the formula. This is a very, very important formula, students. Submerged unit weight by saturated unit weight into tan phi by tan I. This is somewhat an important formula. It has came from here because when the water table is or seepage is present, effective stress will be, when I told effective stress, you calculate effective stress using gamma dash, right? Similarly, my dear students, when you talk about total shear stress, we'll take gamma set. If you substitute this, you will get this final equation. Now, according to this question, in this question, the failure is a rotational failure. In this question, the failure is what, sir? It's a rotational failure. So when they ask you rotational failure, here you should understand that failure occurs along a curved surface. In rotational failure occurs along what, sir? Along a rotational surface. Now, usually the arc of a circle, the failure surface is assumed as an arc of a circle. Okay. Now, my dear students, if they ask you what is the factor of safety for rotational failure, if they ask me what is the factor of safety for rotational failure, it is given by the formula factor of safety is equal to resisting moment upon driving moment. It is given by the formula what, sir? Resisting moment upon driving moment. So what is resisting moment? Sir, when you are trying to go slide, there will be some force which will try to not to slide. That is called resisting moment. So resisting moment will always due to the shear strength, and the driving moment will be always due to the weight, self weight, I can say. So there is an analysis called phi u is equal to 0 analysis. There is an analysis called what, sir? Phi u is equal to 0 analysis. When I talk about phi u is equal to 0 analysis, the resisting moment is given by the formula. They can ask you separately. That is the reason I am giving this. CLR is the resisting moment and driving moment is W into X bar. But in this problem, there is a tension force or tension crack is also developed. So due to that also, due to the tension crack also, there will be additional driving moment. Actually, if there is no tension crack or anything, you can directly take this value as 0. Agree? You can directly take this value as what, sir? 0. Now, my dear students, in this question. What is the cohesion value? We'll see. Here, the cohesion, undrained cohesion is given as how much, sir? 30 kilopascal. Now, when they give you here, sir, here they give you, this is called length of the arc. We call this as what, sir? Length of arc. Sir, you might be aware of the formula. You know, right? Length of an arc is given by the formula r into theta. If you know, don't know this also, please try to write, sir. Area of sector is given by the formula x by 360 degrees into pi r square. Okay. This is the length of the arc formula. This is the area of the sector formula. Okay. Now, here in this problem, the cohesion is given as factor of safety. Cohesion is given as how much, sir? 30. Radius, length of the arc is nothing but r theta. Radius is given as 14. Here in the question, the radius is 14 and angle is given as 80 degrees. Sir, here please understand here theta value is given as 80 degrees. So you have to convert this value into radians. So 80 into pi by 180. So CLR 80 into pi by 180 into 40. Now we have to find out what, sir? Weight. So you know gamma is equal to what, sir? Weight by volume, right? So here weight can be written as what? Here weight can be written as gamma into volume. Again, volume can be written as what? Area into length. So weight is equal to gamma into area into length. This is the formula. Here if you see, the area is given as how much, sir? Area is given as, gamma is given as 20. Area is given as how much, sir? 150. If you see here, in the question they have given, sir, please second. In the area is given as 150 meter square and the length of the width is they have given is what, sir? Okay, if you see here, the length is also given, sir. The considered 1 meter runoff of the bank for the analysis. So we can take for 1 meter here. Okay. So here if I see here, so 20 into 50 into 1. So this is 20 into 150 into 1. And this, if you see here, the centroidal distance here, see students, here if you see, this is nothing but we call it as x bar. That is given as how much, sir? CG distance. Here you can say the x bar is given as how much? The x bar is given as how much, my dear students? 2.5. Now you have to find out the additional force here. So here, when they give you the additional force here, if you consider here the pore water pressure, usually what is the pore water pressure force? Usually the pore water pressure is given by the formula half into gamma W into Z square. Because vertical stress will be taken as gamma into W, area of the pressure diagram is nothing but force. And it will act from here to here. The centroid distance will be 5.5 meter plus from apex it will be 2/3 of height. So 2/3 into 2.5. So this is what, sir? Centroidal distance. And here we have depth is how much, sir? 5.5 square. So here PW into Y bar. So PW is given force, or you can say force due to PW is given as gamma into what, sir? Y. PW is equal to, due to pore water pressure, half into gamma W into Z square. And Y bar is what, sir? It is acting at a distance 5 plus From apex it will be 2/3 height. So 2/3 into 2.5. So here if you substitute this, half into 9 gamma W is 9.81. Z is how much, sir? Z square is 5.5 square. Here it is 5.5. 5.5 square into 5.5 plus 2/3 of 2.5. Okay. Now, my dear students, if you solve this, you will get the final factor of safety as 1.06. Okay, this is the factor of safety for what, sir? This is the factor of safety for what, my dear students? For rotational failure, you should understand here. I hope you are clear. Just go through the question here. Sir, here if according to this question, I will tell you, factor of safety is nothing but resisting moment upon driving moment. Here resisting moment is nothing but what, sir? C into L into R. Here cohesion is given as 30. Length is given as radius into theta. Radius is 14. Theta is 80 into pi by 180. Into the thing, other thing is 18. Into other value R is 14. Now weight, how I will find out? Gamma is equal to weight by volume. Weight is equal to gamma into volume. Here the unit weight gamma is given as how much, sir? 20. Volume can be written as area into 1 meter analysis, 150 into 1. You will be getting the weight, and after that you will be finding the centroid. What is the centroidal distance? Here we have centroidal distance is nothing but 2.5 meters. After plugging that value 2.5 into the question, you will get W into X bar. But in this question, a tension crack is completely filled with water. So if you consider this pore water pressure, the force is given by half into gamma W into Z square. And this will act from this at a distance of 5.5 plus 2/3 of this height. That will be the PW into Y bar. So if you can solve this question, that would be the sufficient. Next question. A 6 meter thick clay stratum has a dryness at both top and bottom due to the presence of sand strata. The time factor to complete 50% consolidation is 2 years. The coefficient of volume change is given, unit weight is given. What they are asking? Coefficient of permeability. Now, my dear students, whenever these kind of questions are asked, first of all, you should know what is degree of consolidation here. What, sir? What do you mean by degree of consolidation? So here if I talk about degree of consolidation, the degree of consolidation is given by the formula settlement at a time by ultimate settlement. Settlement at a time by what, sir? Ultimate settlement. If they ask you with respect to the percentage, then you have to just multiply with 100. And remember here, my dear students, time factor is a function of U, that is degree of consolidation. You should understand, my dear students, what do you mean by time factor? Time factor TV is given by the formula CVT upon D square. What's the time factor? CVT upon D square. Now, when I talk about time factor is given by the formula pi by 4 into, you can remember as area of circle kind of stuff. Pi by 4 into mu percentile by 100 whole square when the degree of consolidation is less than or equal to 60 percentile. When it is less than or equal to how much, sir? 60 percentile. And time factor TV can be written as 1.781 minus 0.933 into log 10 into 100 minus U percentile when degree of consolidation is more than 60%. Okay. Now we have a term called CV here. What is CV? CV is nothing but coefficient of consolidation. What is CV, sir? What do you mean by CV? CV is nothing but coefficient of consolidation. So what do you mean by coefficient of consolidation here is, what do you mean by coefficient of consolidation? CV is equal to what, sir? CV is equal to K upon MV into gamma W. What is K here? Coefficient of permeability. What is MV? Volume compressibility. What is gamma W? Unit weight of water. So here if I talk about MV, volume compressibility, it is given as delta V upon V into delta sigma dash. Or there can be another formula as delta H by H into H into delta sigma dash. Where using this formula, you can find the settlement. Okay. Now, my dear students, if they give you D in double drainage, it will be taken as H by 2. In single drainage, it will be equal to H. In single drainage, how much, sir? It will be equal to Any doubts in this? Okay. Now see, sir. Here in the question, they have given degree of consolidation is 50%. So time factor can be written as what, sir? Pi by 4 into 50 by 100 whole square. So if you solve this, you will get a value of around 0.196. Okay. Now you know time factor TV is equal to what, sir? CVT upon D square. So time factor at 50% is 0.196. And CV can be written as what? K upon MV into gamma W T upon D square. This is the formula. So in the question, if you see here, what is MV given, sir? Here MV is given as 0.196. K is equal to coefficient of permeability. Here MV is given in the question as 1.51 into 10 power minus 3. And you know, my dear students, here, you know in the students, okay. Here you know what is gamma W? 9.81. And time is given as how much, sir? 2 years, right? 2. Upon thickness is given as double drainage 6 by 2 whole square. Just see here, sir. This is the coefficient of compressibility. And we have the time is 2 years. And we have another thing, what, sir? A 6 meter thick layer, double drainage. So if you solve this, you will get coefficient. K is called what, sir? Coefficient of permeability. What is K called? K is the coefficient of permeability. What is coefficient of permeability, sir? This will be taken as 0.013 meter per. Remember, sir, velocity unit, coefficient of permeability units will be same as velocity units. So please write down this. Okay. Next. Now see here, students, for a flow net diagram drawn under a concrete dam, the following information is observed. The head difference is observed as 9 meter. The total number of equipotential line drops is 10. The length of the field net is 1 meter. If the field below the saturated unit weight is 21, unit weight of water is 9.81. Then the factor of safety against quicksand condition. Sir, first of all, you should understand what is quicksand condition. Okay. If they ask you what is quicksand is, in quicksand condition, if the upward seepage pressure becomes equal to the submerged unit weight, then the soil loses all its shear strength. The hydraulic gradient at quicksand condition is called critical hydraulic gradient. And usually the quicksand condition, the hydraulic gradient at quicksand condition is known as what, sir? Critical hydraulic gradient. So what is critical hydraulic gradient is, this is given by the formula IC. Critical hydraulic gradient is given by the formula IC. IC is equal to what, sir? G minus 1 upon 1 plus E. What is critical hydraulic gradient? IC is equal to what, sir? G minus 1 upon 1 plus E. Or you know gamma dash can be written as gamma W into G minus 1 upon 1 plus E. There is another case where we can write this as IC. So IC can also be written as gamma dash by gamma W. Okay. Now remember, my dear students, what is a flow net? What is a flow net? In flow net, my dear students, here we have, it is a combination of streamlines and equipotential line. A streamline is also known as flow line. Line joining equal potential or equal total head. In soils, remember, my dear students, velocity head is neglected. In soils, what head is neglected, sir? Velocity head is neglected. So the line joining equal total head is known as what, sir? Equipotential drop. The flow line means it is the line along which a water particle travels. Usually, flow line and equipotential lines will be perpendicular to each other. The space between flow lines is known as flow channel. The space between two adjacent flow lines and two adjacent equipotential lines is known as field. Now, if they ask you what is I is nothing but hydraulic gradient. Sir, here I am talking about critical hydraulic gradient. When the word critical hydraulic gradient comes, it is used in the case of quicksand condition. Here hydraulic gradient is nothing but delta H by L. Here, what do you mean by I, sir? Loss of head per unit length. Okay. So here I is nothing but delta H by L. Now again, if there are n potential drops, delta H can also be written as H upon ND, where capital H represents the total head difference, ND represents what's the number of potential drops. Now, my dear students, here, factor of safety for piping is, or quicksand condition is given by the formula IC upon I. Now, similarly, they can ask you, what is the quantity of seepage? Quantity of seepage is nothing but KH into NF by ND. What is NF by ND? NF is nothing but number of flow channels. ND is nothing but number of potential drops. Here NF by ND is nothing but called shape factor. Okay. Now, my dear students, here they have given number of potential, head difference is 9. Now here hydraulic gradient is equal to delta H by L. Now here head loss is 9, potential drops is 10. You can write here delta H can be written as H by ND into L. So upon 1 meter. So hydraulic gradient is nothing but 0.9. Now what is the critical hydraulic gradient? This is given by the formula G minus 1 upon 1 plus E is equal to gamma dash upon gamma W. Now how to calculate gamma dash? Here gamma sat is given as how much, sir? What is the value of gamma sat here given? The gamma sat is given as 21 kilonewton meter cube. So here if you see, gamma dash is equal to 21 kilonewton per meter cube. So critical hydraulic gradient IC is equal to 21 minus 9.81 divided by 9.81. So what will be the critical hydraulic gradient? Can anyone tell me, my dear students? This will be taken as 1.14. Now if you see here, the factor of safety for quicksand or piping condition, sir, usually the factor of safety should be more than 1 for not to occur. So the factor of safety is given by the formula IC upon I. Here what is IC? IC is nothing but equal to 1.14 divided by 0.9. So this will be equal to roughly 1.27. So whenever they ask you what is quicksand, sir, quicksand is not a type of soil. It is a condition which is observed in cohesionless soil, because the shear strength will be reduced to 0. Because if you take cohesive soils, when the effective stress is 0, it doesn't mean that shear strength is 0, because it has some cohesion. So quicksand is a condition observed in soils. So at quicksand condition, we call the hydraulic gradient as critical hydraulic gradient. At quicksand condition, we call the hydraulic gradient as what, sir? Critical hydraulic gradient. And these are the formulas where you have to keep a note of it. So please write down this. Done, sir. Next, the most suitable soil, the permeability of clay soils. Okay, we have different tests, sir, here. Let us discuss. The answer here will be falling head test, because for clays it is falling head test, or we can say variable head test. But let us discuss what is permeability. So here if I talk about permeability, my dear students, permeability is nothing but the property of the soil. What, sir? It is the property of the soil which allows the passage of flow through it. Permeability is nothing but what, sir? It is the property of soil which allows the property of the soil which allows the passage of flow through it. The permeability of the soil is nothing but the property of the soil which allows the passage of flow okay. Got it, sir? This is nothing but permeability. Now, my dear students, when I talk about this is the actual property. So we have different tests. First test is constant head test. Sir, in this we call it as constant head test. Sir, in the name itself, in the constant head test, in the name itself, the head is maintained constant. Okay. Sir, in the name itself, head is maintained. Head is maintained. Head is maintained what constant? Sir, it is very difficult to maintain the head constant for fine-grained soils. Hence, it is very difficult to maintain the head constant, because due to the settling, the head keeps on changing. So constant head test is suitable for coarse-grained soils like gravel and sand. Now, my dear students, in constant head test, we know already velocity is proportional to hydraulic gradient according to Darcy's law. or V can be taken as I into K, where K is the coefficient of permeability. Now, according to the continuity equation, Q can be taken as AIK. So, Q is equal to taken as AIK. Next. Now, my dear students, when I talk about falling head test or variable head test, when you ask you falling head test or variable head test, in the name itself, what sir? In the name itself, the head keeps on changing. Sir, in the name itself. And this happens for fine grained soils. Falling head test is suitable for what, sir? Fine grained soils. So, what are fine grained soils here? What are fine grained soils, sir? This is nothing but fine grained soils are nothing but clayey soils. What are fine grained soils? Clayey soils. If you see the variable head test, it is given by the formula K is equal to AL by AT into ln of H1 by H2. Sir, here what is A? Small a is the area of standard pipe. Capital A and L are area of length, area and length of soil sample. What is capital A and L? They are nothing but area and length of soil sample. T is the time taken for head falling from H1 to H2. Okay. T is the head falling from what, sir? H1 to H2. Sir, see, this pumping out test, these are used for large engineering projects. This is useful for what, sir? I am telling you, because if you remember in this way, you would get you more benefit. Constant head test is useful for what, sir? Coarse grained soils. Pumping out test for large. This is helpful for what, my dear students? This is helpful for large engineering projects. Next, hydrometer. Sir, actually in soil classification, we have coarse grained and fine grained. So in coarse grained, we use relative density and sieve analysis for classification of coarse grained. Hydrometer test is based on settling velocity. It will help for classification of fine grained soils. This will be helpful for what, sir? Classification of fine grained This is applicable for fine grains. This falling head test is useful for what, sir? This is useful for fine grained soils. This is helpful for what, my dear students? This is helpful for fine grained soils. What are fine grained soils here, students? Fine grained soils are nothing but clay, silt. So just go through this slide, students. Got it, sir? I hope you are clear. Now, this is actually, we call it as plasticity chart, sir. This is a question they have given you here. Let us discuss this plasticity chart. Just a second, students. I'm trying to draw the diagram here. Sir, this we call it as plasticity chart. It's a graph drawn between plasticity index and liquid limit. What, sir? What is the graph? This graph we call it as IP. IP is nothing but liquid limit minus plastic limit. This we call it as plasticity index. Liquid limit is the minimum water content at which the soil has small shearing resistance. So here, my dear students, there are some values here, 35, 50, and this we call it as 20. This we call it as A line. What, sir? That we call it as A line. If you talk about equation of A line here, the equation of A line is given by the formula IP is equal to 0. What is IP? Liquid plasticity index. IP is equal to 0.73 into liquid limit minus 20. So here if I consider here 4 and 7, this is CL and ML. I'll tell you what it is. If the liquid limit is less than or equal to 35 percentile, we call it as low compressible. What, sir? If liquid limit is less than or equal to 35, we call it as low compressible. Okay. If the liquid limit is 35 to 50, we call it as intermediate compressible. If liquid limit is more than 50, we call it as highly compressible. Agree, sir? If the liquid limit is less than or equal to 35, it is low compressible. Now, above A line, we call it as, usually above A line, we have clay. Below A line, we have silt or organic soil. Again, for this differentiation, we have different tests, color test, order test and all. So here we can write Cl, Ci, Ch. The answer here is, what is asking is, what is the X here? The X is nothing but what, sir, here? The X is nothing but here. If you see by the explanation, X is nothing but highly compressible clay. So above A line here we have, so eliminate silt. Wherever there is a silt, no. And here we have medium plastic. The option C is the right answer. So my dear students, I hope this video, this session will create you like what actually the concepts related to the gate question they can ask you. So in the coming sessions, I'll be taking more and more sessions. If you are trying to attend more and more sessions, then definitely it will boost my confidence and be taking more and more. But let me tell you, when you are preparing for gate exam in civil engineering, geotechnical is a very important topic. Like topics like properties of soil, shear strength, consolidation, pile foundation, stability of slopes, earth pressure and shallow foundations. We can expect 100% from these questions. And one more important point, my dear students, for any job notifications or for any general information related to the gate, or if you want to have the look and feel of the gate coaching related to civil, mechanical or ECE or CS, we are providing the gate zero fee program in the description. Just click on the link and you can access the free videos and then you can have the look and feel of the gate exam. I hope this session will create you some awareness about the geotechnical problem solving skills. Thank you and all the best.